Hi guys, I hope everyone is well. Let's look at the gradient, right? So the gradient is given by change in y over change in x. Sometimes it's given by rise over run. Sometimes it's given by y2 minus y1. Okay, yes. Oh, maybe I'm not happy with how I wrote this. Ooh, let's see. Maybe let's start by saying that it's given by run. Oh no, by rise over run. Rise over run. Then it's given by change in y over change in x. Then it's given by y2 minus y1 or x2 minus x1. I'm more happy with that, right? So what does a gradient mean just in English, not in mathematics? A gradient is just a slope, right? It's a slope, right? So you always look at, if you want some steps in, let's say quick steps. This idea of rise over run is that how much do you have to lift your foot as opposed to, or as a ratio of how much you have to travel across with your foot. So that's the idea of rise over run. And if that ratio is the same, then you can kind of talk about a certain steepness, right? So this line would be a particular steepness. However, I don't want to talk much about that. I would really love to talk much about it. But anyway, gradient is given by mostly y2 minus y1 over x2 minus x1. Someone could ask right now, does it matter if I say y1 minus y2 and x1 minus x2? The answer is it really doesn't matter. So you can say this is y1 minus y2 over x1 minus x2. What is wrong? You cannot mix them up, right? So what is wrong is that you cannot say y1 minus y2, then you say x2 minus x1. That would be incorrect. Right? So I mean, I would love to go into details of that slope idea, but perhaps let me not. This is just for exams, so let me not take you that far. So now you can imagine if you have two sets of steps, right? Maybe this is how I can just exploit it. If you have two sets of steps where you have to rise, you have to run the same way as you rise, run the same way as you rise, run the same way as you. So if you have the same set of steps, if you have the same set of steps, right? If you have the same set of steps like that, then it basically means that you can just have that line going there like that. I changed the color of my steps. Maybe I didn't intend to do that. Change it back. So even here you can have the same kind of, because you have this same rise over run. If you have the same rise over run, just write this differently. If you have the same rise over run, it basically means you have the same change in y over change in x, which means that you have the same of that, right? If you have that for two different lines or steps, in this case, whatever, but ultimately lines, even if it's steps, what you end up having, it's line. It clearly that those lines are parallel. And therefore, if your rise over run for this one was the same as the rise over that, it basically means that M1 is equal to M2, right? I can say this simply by saying that if you have parallel lines, you have the same gradient for those slopes. or for those lines. You have the same gradient for those lines. Okay. Now let's talk about another set of lines. All right, probably talk about 3 sets of lines. I'll just give this up front. So let's do it. I think I should actually give it up front in a more. So if you have 2 lines, I know I wrote these lines very conveniently. M1 and you have M2. So meaning that these are not lines to pick, nice lines to pick, because they have their properties. So you have that line, and let's pick another line, and you have, I'm sorry about this, we pick another line, I'm not happy about that one, yes, and you have that other line over there, right? So these lines happen to meet at 90 degrees. What we say is that this would have its own gradient, the rise over this, and then also this would have its own gradient. Right. So we then say, when you consider the product of this line, when you say M1 times M2, you will always get -1. So the product of the gradients of lines that are perpendicular, it's always equal to -1. Right. Guys, what I'm doing here, I'm dishing out properties. Before you start doing examples, know what are the examples based on. Know the principles. I'm not sure if I've ever told you about how I study. How I study is I try to understand the principle and then do a few examples, or maybe many, depending on how I feel about the topic, and then I go. But I do not jump on doing examples not knowing the principle. That's a recipe for disaster. Okay, one last principle when it comes to gradients. Maybe there are quite a few more. If you have a particular line, I'll call this a collinear lines, collinear points. This is the same line. So if you have point A there, point B here, point C, and they all line in the same straight line, right? It basically means that the gradient of AB, so the gradient that you get when you use that point and that point, is going to be the same as the gradient that you get when you use this point and that point. So it's going to be the same gradient, and that gradient will also be the same as when you use that point and that point. So that gradient is going to be AC. This is an amazing property of a line, and it basically means a lot of things. You're going to see where it's used, but the simple one, it basically means that if you have the gradient of AB, you can use that gradient to try to find a missing point in C, because you'll just say the gradient of AB is equal to the gradient of AC. You already have the gradient, then you can play around. I'll show you in some examples. Then I just wanted to talk simply, which is probably the last part. I've spoken about this on Saturday, so yeah, I'm just going to reiterate. So if your gradient is greater than 0, then your line is like that. If your gradient is less than 0, then your line is like that. If your gradient is equal to 0, it means it's a flat line, it's not steep. If your gradient is equal to undefined, it means that your line is vertically up. Right? And I've spoken about why these things are. If you still have problems with that, please talk to me. The best way to do well in this exam is to make sure you get the principles before you start practicing. I'm not going to repeat that anymore. Okay guys, I'll see you in the next video.